Okay, in this example we've got vector p which has a magnitude of 8 and makes an angle of 50 degrees below the I direction. We need to write p as a column vector correct to 3 significant figures. So let's start by drawing a vector of magnitude 8 50 degrees below the I direction. And then we'll add an extra line in to make it into a right angled triangle. And we are looking to find the components which we'll label x and y. To find the values of x and y, we can use right angled trigonometry. If we want to find x, we've got the adjacent and the hypotenuse, so we can say cos 50 equals x over 8. Multiplying up by 8 gives us x equals x cos 50. And if we put that into our calculator, we get 5.14 to 3 significant figures. In a similar way, we can find y. We've got the opposite in the hypotenuse this time, so we've got sine 50 equals y over 8. Again, we multiply up by 8 to get y equals 8 sine 50. And if we put that into our calculator, we get 6.13 to 3 significant figures. So we can now write our vector p in column notation. So we get p equals 5.14, 6.13. Okay, here's a similar problem for you to have a go at for yourself. Pause the video and then come back and check your solution against mine. Welcome back, here's my solution. Well done if you got it right. If not, I'll go through how I got my solution now. So in this part we have vector q with a magnitude of 9 on a bearing of 82 degrees. We want to write it using unit vector notation. Let's start by drawing a diagram. So our angle is measured from north. Next we need to turn this into a right angled triangle. There's a couple of ways of doing it. The way I'm going to do it is like this. If you did it differently, that's okay. You can still get the same answer. To get the angle inside my triangle, I can use the fact that north and the I direction here are going to make a right angle. So if this is 82 degrees, then I'm left with 8 degrees for the other angle. I'll call the base of the triangle x and the height y. Next we need to find the values of x and y. X is the adjacent side, 9 is the hypotenuse, so we get cos of 8 degrees equals x over 9. Multiplying up by 9 gives us x equals 9 cos 8 degrees. And if we put that into our calculator, we get 8.91 to 3 significant figures. To find y, we're going to be using opposite over hypotenuse. So we get the sine of 8 degrees equals y over 9. Again, multiply up by 9. And then pop that into our calculator to get 1.25 to 3 significant figures. Finally, we write it using unit vector notation. So we get q equals 8.91i plus 1.25j.